Everyone. So, very quickly, this is going to be one of the last things that we're going to talk about as far as the basis for linear motion, which is about acceleration. So far, we talked about how far an object travels. We can either describe it in terms of distance or displacement, and we talked about how fast it can get there, how fast it can travel using speed or velocity. Next is the obvious step forward is acceleration. So acceleration is basically how quickly we can change our speeds. Because it turns out, as you may know, that speed and velocities aren't always constant. You go on a road, you increase your speed, you decrease your speed, you come to stops, you keep going, all those things. So, we're going to end up wanting to talk about this term acceleration. Acceleration is going to be described using the symbol A or represented by the letter A, and it's described as the rate at which a person's speed or velocity changes. Acceleration and velocity are not the same thing. All right, this is a big important thing. The reason I say this is because a lot of times people think that just because you're moving in a direction means you also have to be accelerating in that direction, or just because your velocity is increasing, then your acceleration has to be increasing. They're not the same. They're related, but they're not the same thing. All right. So now the units. So the units for acceleration are meters per second squared. You want to make sure that in your mind you link the unit, meters per second squared, with the acceleration. Likewise, you want to also make sure that you link the other units, velocity and speed, with meters per second, and distance displacement with meters. Now, I had mentioned in class before that this is not a class that requires memorization. That it's not one of those classes where you can sit down the day before a test, flip through some flashcards, or memorize what you wrote in your notes and expect to do amazingly well on the test. For the most part, if you did that, if you just tried to memorize everything, I would be surprised if that still allowed you to pass if you weren't also practicing the other questions. This class really hinges on the fact that you are doing active practice with these problems. The one thing that I would say is that a lot of people will sometimes have problems with the units, especially in this beginning part. This is actually, despite this topic being fairly straightforward and fairly easy of a topic compared to some of the other ones, um, a lot of people are going to struggle with this, mainly due to the introduction of these different types of measurements and their units, especially since they're all going to be very similar: meters, meters per second squared. If you find yourself doing problems and having trouble figuring out which of the variables that they give you, which information is what, if a number is supposed to represent a velocity, an acceleration, or a speed, or a distance, then I would recommend for this having flashcards just to link units with the variables. So you'd have, acceleration on one side, the unit on the other. Or you could do something different where you have a number with a certain unit and you have to immediately guess whether it's an acceleration, a speed, or a distance. Again, this can save you a ton of time on a practice on a problem where you just read it. You literally just look at the number and the unit next to it, and you already know what that's supposed to represent. You see meters per second squared. That has to be an acceleration. No ifs, ands, or buts. All right. So I just wanted to kind of mention that. Now, one other thing that I want to mention is the definition for acceleration is officially how quickly we can change our velocity. Even though I did add in speed in there, it's actually strictly connected with velocity. That means acceleration is a vector, and vectors require direction. Direction is important. Um, and not only that, because there's this relationship between velocity and acceleration, the direction of both is important. So, for example, if the velocity and the acceleration are going to be pointed in the same direction, so both of them are pointed to the right, both of them are pointed to the left, something like that, then what ends up happening is the object's speed will be increasing. Again, this kind of makes sense. You know, if you are moving in a certain direction and then something's causing you to start to accelerate in that direction, like maybe someone pushes you, then all of a sudden your speed is going to start increasing. On the flip side, if the velocity and the acceleration are pointed opposite directions, so one's pointed to the right, the other one's pointed to the left, then the object speed will end up decreasing because of this. Again, going back to that same scenario, a person can stop a moving car by pushing in the opposite direction, uh, which is essentially giving it a opposite acceleration. So it's moving in one direction, but it's being accelerated in the other direction. Usually we call this a deceleration. But in terms of physics, we usually use the term acceleration for both types, increasing speed and decreasing speed. There is a third scenario of when the velocity and acceleration are pointed in different dimensions, in the sense of one's pointed like this and the other one is perpendicular to it. But we'll discuss that in about next quarter, I would say. All right. Now, on to the equations. Now, there are two equations that we're going to work with, but they're really kind of the same equation. After we do a few practice, I'll show you some of the more extensive and more complex equations. All right. So the first equation that we have is this: A equals delta V over T, or Vf minus Vi over T. So this is just kind of going back to the definition of acceleration. Acceleration is the rate of change in the velocity. So it's the change in the velocity divided by time. Anytime you see this, delta V or delta anything, that means that we're taking the velocity and we're going to subtract final minus initial. All right. So another way we could write this is Vf minus Vi divided by T. So our final velocity minus our initial divided by time. Remember, you should be following along on the guided notes. You should be writing this equation, and I do recommend that on the right hand side you write down the units. This is meters per second squared. The velocities are both meters per second, and the time is seconds. All right. Now the other equation is the same exact equation. It's just taking this and rewriting it. So we move the time over next to the acceleration, and we move the Vi over here, and we get this: Vf equals Vi plus At. Me personally, I always recommend this equation, just because, again, it's simpler. It's something that people will be able to solve much easier. While even though this can still be solved easily, some people will make common mistakes. All right. So yeah, I say that these are two equations, but it's really the same equation, just written differently. All right. So first question. Pause video, work on self, and we'll go over in a second. Alright, so as we read this, the car is being driven south, so the velocity is south, and then it says it's decreasing in speed. And they want to know the direction of the car's acceleration. So because it's decreasing in speed, we know that they have to be pointed in opposite directions. So the velocity is south, the acceleration has to be opposite south, which is north. And there we go. That's pretty much all this says. Again, remember, these are supposed to be multiple choice questions. I just rewrote it so that they were more free response. Alright, next question, number 15. So pause video, work on itself, and we'll go over in a second. Alright, so remember, one of the big things that we want to do is we want to write down everything that's given to us, and then show our entire work. Remember, even though this is for your own benefit, like you're only filling out notes, something that only you will see, it's still important to get into that good habit. And you know what? The more you do it now, the less you will have to do it in the future. All right. So reading this, so I have a meters per second here, meters per second. These are both speeds. So we have two speeds, and this is seconds, so this is going to be a time. Now it tells me it's initially running at 5 meters per second, so that means it's a initial speed. This, it speeds up to this, so this is what's going to be my final speed. These are our main types of speeds. Remember, there are three speeds: initial speed, final speed, average speed. All right, and then as I said, this is time, so our time is 4 seconds, and they want to know the acceleration. So only one equation has all this, so I'm going to use VF equals VI plus AT. Remember, I like to use that second form, even if I'm solving for acceleration. So I plug my numbers in. Note, I am still putting in my units. Technically, I wouldn't need to since I have this stuff written down, but it's still good practice. Move things around, solve, and I get my answer is 1 meters per second squared. One thing I want to note is this. Even though I keep harping that acceleration is a vector, which means it has a direction, I do not need it because this term tells me I don't need a direction. That's all this word means. If you keep getting stuck on the word magnitude, because a lot of people will ask me, what's the equation for magnitude? You could just cross it out, because for the most part, it isn't really going to affect your answer. There are only a few cases where it might be an issue, and that's if you see 1 meters per second squared and 1 meters per second squared east as your choices, in which case you would want to go back and figure out, well, do I care about direction or is it useless? All right, here's the next question. Pause video, work on itself, and we'll go over in a second. All right, so when we read this, I see meters per second, so I see that this is a speed. So this is speed. I see 3 meters per second squared, so I know that this is an acceleration. And over here it says how long it takes to reach the speed. So this is a time. All right. Now, here's the thing. I'm looking for time. Now, in my mind, I know the equation requires two speeds. I know this is one speed, but what's the other? This. It accelerates from rest. Rest is implying that I start at 0 speed. Because it's not a number, some people will tend to overlook this term. Try to avoid that inkling. Anytime you see rest, immediately know that something is 0. So our initial speed 0, it's going to 30 meters per second, so that's our final speed. And again, our acceleration is 3. So solving for the time, I'm going to once again use the acceleration equation, the only one we know as of now. Plug my numbers in, and I get 10 seconds. Now the next question says, how far does the car travel in this time? So this is a distance that I'm looking for. So far, I have a VI, a VF, a T, and I'm looking for D. Now the only equation that I know so far is the equation V bar equals D over T. V bar is not given. This is an initial and this is a final. This is V bar. There's a specific reason I always stress that this is V bar. It's an average speed. It's different from these two. Again, we have 3 speeds that we have to take into account. So that means I have to do 2 things. If I'm going to use this equation to find distance, I need to first find the average speed. So the average is going to be 15. Think back to one of our equations for average speed. It's the sum of the two speeds divided by 2. 30 plus 0 divided by 2. That's 15. My time is going to be 10 seconds, and now I can use v bar equals d over t. 15, blah, 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 and I get 150 meters. Now, if you didn't like doing that, if you didn't like having to do two steps of finding the average speed and then using the equation, don't worry. In a bit, I'm going to show you some new equations, some better equations that will allow you to solve these questions much quicker without having to go through this, whole song and dance with average speed, which is one of the reasons why I say for the most part you will pretty much always ignore average speed equation. Alright, here's the next question. Pause the video and work on this stuff. I'm going to go over in a second. Alright, now some of you probably made a mistake with this, so we'll go over it very quickly. So this is a speed, and this is a speed, and this is a time. Again, I'm looking at the units. I'm barely even paying attention to the question for now. Alright, so then it says it's traveling to the right at 9 meters per second. Okay, so this is my initial speed because this is what it was initially traveling at. And then it bounces off, so then this is my final speed. And they want to know the acceleration. So what I'm going to say is I know my initial speed is going to be 9 meters per second and my final speed is 9 meters per second. So the equation I'm going to use is VF equals VI plus AT. Now here's the problem. I've been calling these speeds, but remember, in this equation, this is not just final speed and initial speed, it's technically final velocity and initial velocity, which means there's one thing that is very important: direction. Most likely, a lot of you have probably put in 9 here, 9 here, and ended up getting that the acceleration was 0, but that doesn't make sense. That's wrong. What ends up happening is I have to distinguish that one of these speeds is going to the right and one of these speeds is going to the left. So the way I do it is by making one of them positive and the other one negative. So I'm going to say that my initial speed is my initial velocity is a 9 meters per second, but then my final velocity is going to be negative 9 meters per second. And my time is going to be 0.2. So that's going to be the big trick for this problem. So plugging that in and making sure that the final velocity is negative, I end up getting that my acceleration's 90 meters per second squared. Once again, major question some people might be thinking is, where did the negative go? Negative 18 divided by 0.2 is not a positive number. Once again, magnitude. For the most part, if you gave me a negative, you would not lose points. Just saying. Like I said, it's only for certain multiple choice questions where putting a direction or putting a sign will cause you a problem. But doing it on a free response, all we care about is the number. Alright, so right here I want you to think about one of the experiences you've had where you've accelerated. Typically, common places where you would feel acceleration would be things like in a car, when someone's speeding up or slowing down, anytime you go on a roller coaster ride, or if you've ever gone on one of those, the Gravitron, or the teacups. So I want you to think about, what did it feel like, and would you be able to tell if you're accelerating with your eyes closed, and how could you tell when you were accelerating a lot compared to a little? Alright, so I just want you to think about this for a bit. This is going to be a question that I'm going to post to you guys at some point. There's a video that goes along with it. I'm not going to play it at this moment, but it's about a bungee jumper, and I want you to try to think about, where do you think that you would feel the greatest acceleration if you ever bungee jumped? But again, I'm going to show that a little bit later. I guess I'll show this now. So there are, I said before, extra equations that we can use in order to find some of these things, find distance and acceleration and link them up. So these are the equations that I would highly recommend that you try first. So the first equation is this: d equals vit plus 1 half at squared. This equation is what I call the magic d equation. This is going to be your best friend in the next topic. It's usually the equation I recommend you go to first. The next equation that we have is what I call the timeless equation. Vf squared equals vi squared plus 2ad. I call it timeless because this is the only kinematics equation that doesn't have time. So if you're doing a problem and time is never mentioned in the question, then that means you're using the timeless equation. The other equation was the acceleration equation, the Vf equals Vi plus At. So if you look on the reference table, this is, I think, the fifth equation or so. This is the fourth equation. This is the third equation, yada, yada, yada. What I usually tell people is work backwards. When you're doing a problem, you now have to juggle 5 different equations. You have to figure out which of the 5 you're going to use. I always recommend checking the magic D first. So this should be your first equation you check. Then you should check this equation. Then you should check this. If none of these work, then you can do the average speed equation. But again, magic D first. So pause the video, work on the stuff, and we'll go over it in a second. Alright, so this is the very last question that we're going to do together, in this video at least. So once again, I'm going to write down what's given. Again, looking at the units, meters per second. This is a speed. This is a distance, because this is in meters. And they want to know the deceleration. So writing everything down, my initial speed is 100, but then it tells me that it comes to a halt. So this is my key phrase, comes to a halt, telling me that the final speed is going to be 0. The distance is 70, and the acceleration is what we want to know. So looking at it, the magic D doesn't work. There's time in that equation, but there's not a time in here. So I go to the next equation. Vi, Vf, D, and A. The equation I'm going to use is the timeless equation. Plug my numbers in, do the math, and I get that the acceleration, or in this case the deceleration, is going to be 71 meters per second squared. And that's it. That's all you have to do with these questions. So if you have any other questions or concerns about this, please let me know as soon as possible. Again, any practice problems, I highly recommend that you show all the work that I show in here, and also make sure that you're working backwards, that you're or looking at the equations backwards. You start with the magic D first, the timeless, and do it that way. All right. Good luck and have a great day.